Science class today will start off at exercise 3.1. 3.1 on page 82. Today is 28th Feb. Boom. Alright. So a cricketer hits a ball straight up into the air and its velocity initial is 20 meters per second. We'll assume upwards is positive and work with that, right? So what height does the ball reach before it stops to fall to the ground?
Maximum height.
We need to find H max, né? But also, do we know anything about the time it takes? We don't, né? Okay, so we must find H max.
We only have initial velocity. We know that final velocity is 0.
Yes,
Because
final
maximum height.
is 0.
And acceleration, depending on which direction we're taking, it's 9.8 meters per second.
Negative 9.8 meters per second squared because it's acting downward, and we've assumed positive to be the up direction.
Yeah. And then
okay. Just trying to remember which equations we could use.
we'll take out the book so that we don't have to scroll. I need to wash this jacket. I don't like how it smells. I don't like how this jacket smells. My jacket.
Why?
My jacket.
Now you're making me self-conscious of that.
My jacket. I don't like how it smells.
Okay.
So yeah.
So which equations can we look at?
We're looking for
The maximum height.
right?
Yeah.
I think the VF final is equals to V initial squared. V final squared is equals to V initial squared plus 2A change in time. Change in
displacement. So it's VF squared, right?
Yes. Is equal to V initial squared plus 2 multiplied by acceleration due to gravitational force multiplied by
change in displacement. Okay. So we've got 20 squared equals 0 plus 2 times negative 9.8 times y, and that's gonna be negative, right? Equals negative, that's 18 plus 1.6, 19.6 y. Therefore, how much is y? Should be 20 squared is 400, right?
I believe so. Yes, it's 400. So the negatives cancel out each other. 400 over 19.6. 20.41.
Okay, so it reaches a maximum height of 20.41 meters. And how long has it been in the air for?
That's when we use this equation of time.
Which one is it? V final?
I don't know, whichever we prefer. Can use this one.
V final.
V final is much more simpler. So V final is equals to V initial plus acceleration due to gravity multiplied by time.
Change in time. And we know VF is 0. That's 20 negative 9.8 times delta t. Then we'll have negative 20 equals negative 9.8 times delta t. Therefore, delta t is what?
2.04.
0.04 seconds.
Yes.
Okay.
It's kind of the same as the 20.41 meters per second. Meters.
Oh, you mean like they have similar factoring?
Yeah.
Factors, yeah. They have same kind of factors. Okay, so we're told that Zingi throws a ball straight up into the air, and the ball reaches a height of 80 centimeters, which is 0.8 meters. We know that it reaches that velocity, or rather that height, at a velocity of 0 meters per second. We know it's subject to acceleration due to gravity, so we'll make that positive this time. So downwards is positive. And so we've got H max, we've got VF, we're looking for initial velocity.
And we can use we don't have time.
But we do have a H max. So
yeah, we have
use
the V final squared is equals to V initial squared plus 2 multiplied by acceleration due to gravitational force multiplied by displacement.
like that.
Yeah.
Alright, so VF, that's 0. We don't know that. We do know that this is 9,8. And we do know that this is 0,8.
Yes.
So V squared initial is negative. Ooh. So 19.6 times 0,8. Oh, that's negative because it goes to the other side. The sign here is positive, right? On the equation.
Yes.
Alright, cool. So what's 19.6 times 0,8? Should be
15,68.
15. 15 point?
68.
68 minus, therefore VI is, what's the square root of 15.68?
3.96.
3.96 meters per second, which is 3.96 meters per second upwards, because our sign is negative. If we'd used a different equation, which one would it be?
We don't have time. We only have displacement, and we're looking for.
We were
Initial
looking for
velocity.
initial velocity. So that would have been the best equation.
Yeah, that'd
right?
be the only equation valid to be
Okay.
used.
Then part B, how long does it take for the ball to reach maximum height?
Okay, that's fine.
V final equals V initial plus
Acceleration.
G delta
Multiplied
T.
by change in time.
Okay. V final 0. That's negative 3.96 plus 9.8 times delta T. 3.96 equals 9.8 times delta T. And how much time does it take to get to 80 centimeters? 3.96 divided by 9.8.
Uh, 0.40 seconds.
0.4 seconds. Alright. Then number 3.
It's not even half a second.
Not even. Is that long? That long. Yeah, it's that long. Tweet, tweet. It's not very long. So a tourist takes a trip in a hot air balloon, and the hot air balloon is moving up Oh, this thing has a cool feature. What's this?
Yeah. Couldn't get it.
Okay.
You wanna
I'm gonna
write?
draw that's a hot air balloon. Oh yeah. Oh yeah. It's a hot air balloon, and that hot air balloon is moving up at a velocity of 4 meters per second, so we'll assume upwards as positive. Then, as the hot air balloon is moving up, a tourist accidentally drops his camera over. Hey, he turned his into the sky. Likes things. Now he's trying to take photos and his camera drops.
Cry.
There's the
Do you know
camera
how
there.
expensive cameras are?
I know, eh?
Especially the Canon one.
Yo, bruh.
Oh.
Tell me about it.
Even the Polaroid is also expensive. The film is expensive.
Oh yeah, the instant film camera.
Yeah.
Oof. I had one of those and then guess I gave it away. So this thing is that I had. It's South Africa. It's South Africa.
I'm going to have one next year. When I go to university again.
Okay, the instant.
And then just so my room can be like aesthetic. Maybe that's going to happen like my second year.
Okay.
Because first year might take some adjustments.
Yeah, it's usually better to plan for a second year.
Yeah, if not towards the end of the year.
Yeah, that also works. So, okay, camera drops all the way from like what, 20-meter height?
It was 20 meters above sea level. And he drops the camera.
Yeah.
Hey, people like to test. They just like to bother God with unnecessary things.
Ish, you know. So wait, I want to understand something. The hot air balloon is moving up at 4 meters per second. And the camera drops as the balloon's moving up. So that means its initial velocity?
Is 4 meters per second.
Yeah, in that direction, in the up direction.
But it's still moving up.
Yeah.
Do you think it left with 4 meters per second?
Like at that speed?
Takeoff was like 4 meters per second.
The thing is, the tourist is in a balloon that's moving at 4 meters per second. As that balloon's moving up at 4 meters per second, the tourist camera drops from a height of 20 meters. Do you think we should assume the velocity initial
for the camera is
to also be 4 meters per second in the upward direction?
I believe so. Kind of makes sense if we put it that way. It kind of makes our situation easier to understand.
To visualize.
Yeah, to visualize and comprehend.
Okay. So there's the ground there. Just draw a tree. Oh yeah. Just to show that the balloon's up there and there's trees.
That looks like a broccoli.
I'm also. How do I make an actual tree now? Okay, this doesn't look like broccoli.
No, this thing is shaped like a broccoli. If you pick up a broccoli, it looks like a broccoli.
And
or cauliflower.
Yeah,
Think about it.
It kind of did. So that's why I'm like, you know what? I want a tree that looks like a tree, not broccoli. So yeah. So now our camera drops. So its initial velocity is plus 4 meters per second. We know that acceleration due to gravity is negative 9.8 meters per second squared, since we've assumed up is positive. We've got a height. I guess H max is 20 meters.
Mm-hmm.
And we must find V final. Which equation can we use?
We have initial velocity, we have acceleration, displacement.
No.
Yeah, I think we're just gonna have to use majority of our equations is going to need that equation. Majority of our problems is going to need that equation.
That equation. I would like to think that that is true.
I said majority, I didn't say
Okay,
all.
but not all. Yeah.
I said majority.
A
Because some
lot
of
of
them,
them,
they
yeah.
require this equation, yeah, displacement is equals to V initial times time and all of that.
Yes.
Yada yada.
So our one. Oh, okay. Delta Y, right? Delta Y. Okay. So we don't know what that is. But we do know that this is plus 4 squared negative 9.8. We've got 20. So this is 16 minus 19.6 times 20 plus negative 19.6 times 20. The 19.6 is negative. Where did I put my phone?
It's negative 376.
So V squared, F is negative 376.
Meters.
Then what's V?
V.
Which is the square root of 376. You must be careful with the signs.
2 to the root of 94. And then let's say 19.4.
19.4 meters per second. That's negative. So that means it's moving at 19.4 meters per second downwards. Where did I put my phone? I left
Your
with it.
blue phone. I never saw your blue phone.
I didn't leave with it. Did I?
Don't know.
I probably. Oh, it's here. So I left it in the bag. Alright. Ball is dropped vertically from a tower. Let's see.
Eiffel Tower.
Yeah. So we've got tower. Building.
This is so cool. This is so cool.
There's doodling feature. I guess that's the beauty of artificial intelligence.
Maybe someday when my little sister has a project, we'll just use that one and tell my dad to print it out.
Yeah, that'll work.
We're still trying to figure out what have you drawn there.
Oh, I've definitely drawn a tower. Which one looks more towery?
They all look like buildings. Let's take that one.
Yeah. And I'll just make it smaller. Alright. And then the ball is dropped from the tower.
It's a ball. Put like 10, make it look like a tennis ball.
Make it look like a basketball.
Okay.
Yeah. So now the ball is dropped. If the vertical distance covered in the last second Ooh, okay. So in the last second as it drops, 1s, the distance equals, okay, so the first 3 seconds, we have a value for delta y, and in the last second, that vertical distance is equal to the distance covered in the first 3 seconds.
Could it mean or the ball was falling faster at the last second?
Probably. But I'm willing to also bet that V initial is 0.
Yes, because the ball is dropped. When the ball is dropped, there's no initial velocity given to the ball.
Yeah.
So yeah.
Then
I'm gonna have to find V final.
V final. G, we'll assume positive is positive, down is positive. G is 9.8 meters per second squared. If we work with the first 3 seconds, you think we could find the change in displacement given the acceleration due to gravity, initial velocity? We've got a measure of the time, so we know that it's 3 seconds.
Won't we have to subtract the last second from the initial second to actually get the total of the height?
So we're saying we subtract this distance from that distance. We can't just, because we still have to figure out what this is. Because we're not told anything that happens after the first 3 seconds, before the last 1 second. We don't know what happens there. But we do know that in the first 3 seconds, the ball drops the same height as in the last second.
Okay.
So let's say it's dropping from the top of the roof.
Okay, so it's not gonna work because if the heights are equal, it's just going to give you a displacement of 0. If you subtract
It will
one
take
from
something like that, yeah.
Yeah.
So we'll have to work with it piece by piece, starting with the first 3 seconds and then maybe doing another calc for the last second. So if we have V naught or V initial for the first 3 seconds, can we find V final? Maybe we could. V final.
We have time.
We've got time, okay.
Okay, we have time, initial velocity 0, looking for final velocity.
Yeah.
And then we also have the time, right? So I think we might use the VF is equals to V initial. That's change in time, change in displacement, change in acceleration due to gravity, multiplied by change in time.
Delta T, okay. So V final we don't know. We know VI is 0. We know this is 9.8. And we know the velocity is, the time is 3 seconds.
It's 29.4 meters per second.
29.4 meters per second. So at this point, so somewhere here, our ball is moving at
29.
Should I want a smaller ball? Okay. So here, so at this point, our velocity of the ball is 29.4 meters per second. Okay. Can we find how high it's traveling now that we've got the final velocity? I think we can. So So it'd be VF squared equals VI squared plus how much? 2G delta X 2G times delta Y. And that's 29.4 equals 0 plus 2 into 9.8 times delta Y. And how much does that give us? So 29.4 minus 19.6. 9.8 meters. Okay.
Yeah,
And we also told it's the same distance it travels in the last second. So in the last second, our V final, we don't know, but we don't really know V initial either. Can we assume that when it drops at a velocity of V equals 0?
Because it would have slowed down.
I mean, on impact when it hits the ground. Okay, maybe that's not a correct assumption to make.
Because it's a ball, it's probably going to bounce
Yeah.
before slowing down.
Yeah.
So hitting it is just going to slow. Hitting the ground is just going to slow down.
Slow it down.
And the ball is just going to bounce.
But, okay, the vertical distance covered in the last second equals the distance covered in the first 3 seconds. So in the last 1 second, it travels 9.8 meters. So we've got a time measure, we've got a displacement measure.
Like acceleration as well.
Got acceleration due to gravity.
I think we can find
the height of the tower.
So you know what I was thinking, because we could use this as initial velocity for this.
For this part here.
Yeah, but I still don't know how that one is going to work. It was a thought.
Because we might have another distance here that we could add to this one here. And if that's the initial velocity, then what's the final velocity there?
I don't know. So it's going to be 9.8 plus x.
Plus that distance would be the total height. I'm trying to think about what's the velocity here? Oh, but we don't know the time between here and there. And we don't know the total time.
I think if we had time here, we'd be able to break it down easier.
We could. Yeah,
solve it easier.
Because I'm thinking about what's the total travel time of the ball. We don't have that. We also have find the height of the tower. Distance covered in the last second equals distance covered in the first 3 seconds. We could, however, find the average velocity in the last second.
Okay.
But that just gives us over the 1 second how fast it's traveling. Well, pretty much before it hits the floor and bounces in whichever direction. And that would be literally 9.8 meters per second. Because it's traveling that distance in 1 second.
Can we assume that the ball slows down? But like, if it covered the same distance, it means it's sped up.
It's sped up, yeah. Okay, let's think about this. If in the last second before it hits the ground, it travels 9.8 meters per second, That's about the same distance it traveled in the first 3 seconds. Where was I going with this? Because I was thinking of, I've got the 3 seconds. We're gonna travel. Okay, I had a thought, but I don't know where it's going now. Where it's gone. I had a thought. We don't know the total travel time, but we do know that this velocity would be in the last 1 second, right?
Okay, so we have velocity, we have displacement, we don't have.
I wanted to find out if we have a velocity vector here.
So we have an equation here. Okay?
Which one is it?
It's change in displacement is equals to v initial change in time plus 1/2 change in displacement times
This
change
one here.
in time. Yes. So what I'm thinking is that we substitute displacement 9,8, which is equals to v initial multiplied by change in time, which is going to be v initial because our time is 1 second, and here we're gonna get that's 9,8
We could try that.
divided by 0,5, 19,6. Is that right?
I'm not sure, because here's what I was thinking, yeah? If in the last 1 second this was gonna travel at 9.8 meters per second, can't that be v final and the v initial would be there
So let's try.
after 3
I think
seconds?
I have faith in this
This one.
equation.
Okay, let's try
I think
that.
I have faith in this equation because we're gonna find our initial velocity.
Okay. So the formula is final velocity,
Change in displacement
change in displacement
is equals to initial velocity
equals v I,
initial
okay,
times
times
change in time
delta t, okay,
plus 1/2
times
multiplied
g,
by g times change in time squared.
okay, and our displacement would be the 9.8. Then vi would be
V
The
initial is
9.
V initial.
just v initial,
Just V initial. We're looking for V initial so
Okay.
we can get V final.
okay, and the time would be the 1 second.
Yes, the 1 second. I don't know where I'm going with this, but
That's fine, let's give it a shot. If the math doesn't math up,
then it didn't math up. So
didn't math up, yeah. So then
so
we're gonna
here
have,
we're gonna have V initial plus 4,9. Subtract them from
9.8
there. Additive inverses.
is would be
4,9.
4.8, 4.7. Okay,
Get initial velocity
that would be the initial velocity where?
for the last second.
So it'd be here.
Yes.
Okay.
We found the height of this thing. We have the initial, and then maybe we can get final velocity for this one.
But why would the velocity drop so much? Somewhere 9.8 meters from where it was dropped, it was moving at 29 meters per second. Ne?
Yeah, and then maybe you can make this an initial velocity for this part of the tower.
I see where you're going, but I just want us to ask questions around the numbers that we're getting.
Yeah.
Because if we're accelerating because of gravity, we should have a higher velocity down there than up there. That's my question I have. So I like the attempt because it shows out of the box thinking. I'm just questioning the numbers we're getting against the science that we know naturally happens, rather. So let's put a pin on it. 4.7. And I think with that, I should also remove this because
So I know where were you going with the 9.8?
meters per second. I was just working out the velocity in the last second of the drop. So that 9.8 meters that it traveled in the last 1 second, how fast was it going? But Leonard also doesn't look right because our thing has a constant acceleration, so our velocity can't be the same or drop as we go. Or could it drop because the air is resisting it? I'm not sure.
For the, can we try this equation for the first part?
For the first
3
part.
seconds.
For the first 3 seconds. This one here. Okay.
I don't know. I'm just trying to figure this thing out.
No, we're doing well. We're just trying stuff out, right?
Yeah.
So the change in displacement,
it's the same equation.
9.8, right?
Yes.
Initial velocity is 0 for the first 3 seconds, right? 0 times 3 seconds plus a half into 9.8.
And the initial velocity is 0.
And what's the time? 3 seconds.
It doesn't make sense. Because we're looking for
sense.
final velocity.
Which we don't have in this
Yeah,
equation, right? Okay, cool.
Equation.
So we can scrap that one. That's fine. Here's what I was thinking.
Okay.
I was thinking about can this VF at the end of a 3 second part of the drop not be an initial velocity of some distance there that we don't know?
It can not.
Can't it be a V initial?
Yeah, that's what I was saying. When we can make that initial velocity and try to find the final velocity here.
At this point here.
At this point here.
Okay, let's do that.
But we don't have the time, neither do we have
the displacement.
Only have acceleration.
Due to gravity. But we could write an equation that we could find another equation to solve with simultaneously.
Okay.
Could try that. So maybe V initial could be 29.4 meters per second. We don't know delta Y. We don't know delta T. But we've got G.
Okay. Sorry, but I tried with this equation. Right. It's wrong. Because I substituted the.
No, it's good that we're talking about it because it means we're thinking about it. And we could use... Okay, we could find the time between the two places if that's an initial velocity and that's a final velocity. But we wouldn't know the final velocity.
Okay.
But we could say that's what VF equals VIM. So we could say VF equals VI plus, what's the other one? G times delta T. Times delta T. So because we've only got 29.4 plus 9.8 times delta T. This can give us one equation. Then what's the other equation?
What are we looking for?
I wanted the one with the displacement, yeah.
V final squared.
So we could say V
Final squared
equals V I squared plus
2 times change in acceleration.
Acceleration due to gravity times the change in time. Okay.
No, not change in time, change in displacement.
Oh, my bad.
It smells like toast.
Cooked meat or something like that.
No, it's toast.
Toast.
Yeah. I deal with it every morning, that's how I know.
Okay. So VF.
And both of them have.
But we know.
We can root this equation in order for us to have VF. That way we have VF and we substitute at this side. But we still have 2 unknowns.
Yeah, we're still gonna have 2 unknowns, that's for sure. So we've got delta Y and VF that we don't know. But now, this one introduces a delta Y. Let's look at the...
This is the equation that we used.
Yeah. Just trying to think, Shoo. Okay, what's this distance here between the last 1 second and the first 30 seconds? It should be, so H total would be 9.8 plus delta Y plus another 9.8. That would give us 19.6 plus delta Y. That's the total height of the tower. Still doesn't say anything here.
Could we have used the wrong equation?
Probably.
Because I think we should have gotten...
Let's pin this one. Wait, what? Check the answers on the exercise and show me your answer. Number 4.
Just press on the number 4. Say tap in. Let's go.
It's not showing a what you call?
Don't press, just tap. Like
I can't tap on the screen.
not like that.
Like how? It's not responding. So when I click the link, practice for learners. Yes, I'm in South Africa. Yeah, I think we need a bit of help from whatever the answer is. Textbooks. Wait, let's first see. It's exercise 31. Let's see. Number 4. Ooh, total height is 125 meters. Yikes, 125 meters.
How is it 125?
Because there must be a distance there that we can work out. Which is what I was.
My problem is that in as much as these people give us answers, they don't show it in step. They don't do it step by step.
It's fine, but that's
It's not fine.
That's the challenge for us to find.
It's not fine. As much as you can say it's fine, it's not fine.
I understand why you say it's not fine, but let's challenge ourselves to find it.
Okay, it's 125 meters.
Yeah, but we don't know that yet. But we do know that the total height is the height that we found out from adding the height the ball travels, first 3 seconds and in the last second. And we know that those distances are equal. But we don't know the gap in between. So we've got the almost 20 meters at the top and the bottom of the fall, and something else in the middle.
Almost 30 meters.
Could be more. But okay, but we do have 29.4 meters per second squared equals. That's not supposed to be 2 times. It's supposed to be just 19.6 because I've already multiplied. Yeah. Okay. So we've got a V final for there. I think we can use another one of those equations to find. Maybe let's revisit the idea you had here. Right?
Because it seems like if the height is from the height of 3 seconds is actually 29.4, it means the height
the
between
velocity at the end of 3 seconds.
Oh, that's the velocity.
That's the velocity, yeah. That's the 29.4. What I was saying is the height is 9.8 meters. So the first 3 seconds height drop is the same as the last 1 second height drop, which is both 9.8 meters.
Which means the distance between those two is a large.
It's a large number.
Value.
Yeah, which we don't know. So I was saying, I wanna revisit the idea you had here of using delta y. Maybe it might bring us closer to actually finding the distance between those 2 points. So we've got VI, which is 29.4. We don't know the change in time, but we've got half times 9.8 times delta t squared. And this gives us 29.4 delta t plus it's 4.5 plus 0.4 4.9 t delta t squared. So check this out. We've got an equation for delta y and delta t where they're both unknowns. And we've got another one we should find
substitute this into
something. So I want an equation, but I want an equation that will make it easy so that if we substitute this where there's a delta y, we also find a delta t quickly. So let's check out our other equation there. That one.
This one. The forgotten.
I think so, yeah.
Okay, let's try the forgotten equation.
Let's try it, because the thing about where I want us to go with this is so that we kind of go into simultaneous equations, you feel me?
Okay.
Yeah. That's because we know the velocity there. We don't know the velocity there. We know it's moving at some velocity, but we don't know how much, what the size of the velocity is. But we found an expression of that distance in terms of the time it takes. We kind of have that expression again if it's the velocity just before the last 1 second starts. We have an expression for that. And we also have another expression with the v final. Oh, no, let's do this. These two equations both have velocity final. But one has delta t, the other has delta y.
Okay.
You said something about squaring, so if we can put a square root here, and we're only left with vf, we can equate that to that one. And then that eliminates vf and leaves us just with delta t and delta y. And then we'll have our second equation
and
that we can equate to here and substitute.
Oh, okay.
Maybe that can work.
Okay, let's try that.
Let's try that. Okay. So
Hopefully
we would.
It works, and I don't have to go through all those long process inside the exam venue, trying to find out what is delta y.
So here we've got vf becomes the square root of 29.4 squared plus 19.6 delta y, and we can equate that to 29.4 plus 9.8 delta t equals square root of 29.4 squared plus 19.6 delta y. That gives us.
You're gonna have to remove
the square roots first, yeah. So we have 29.4 squared plus 9.8 squared times delta t squared equals 29.4 squared plus 19.6 delta y. These are additive inverses. So we're left with
96.4. Okay, it's fine.
Equals 19.6 delta y. Delta y in terms of delta t would be how much?
96.04.
96.04 t delta t squared divided by 19.6, which is divided by 19.6. 4.9 delta t squared. Now, are you seeing that this here is the same as there? So we can say then this is 29.4 delta t plus delta y equals delta y. No.
Okay, say. Additive inverses.
But
they're gonna cancel each other out.
Gonna give us 0 and then our total time is 0. No. That doesn't work. That doesn't look right. But it was a good attempt.
It was a good attempt. Somewhere.
Yeah,
we're on the right track.
We are.
It's just that we lost track somewhere.
We probably need to check our math. Let's start again.
So go back to that page.
This one here.
Yeah.
Okay.
Oh yeah. It still won't work. Even if we substitute this there, it's still going to be the same.
The same, yeah. So we could try something else. Could try something else.
We can make a new equation in on and on.
Okay. What do you have in mind?
I don't know, maybe we can start the equation and then substitute this in place of, I don't know.
Because I wanted to start from scratch by doing this, ne? Right, using this equation and that equation, rather, to equate VF and then eliminate it by equating the two. But I want to inspect the math again.
So,
I want to inspect the math again.
can't we? But no, we're still gonna have changing time. Still gonna have two unknowns as well.
Okay, let's start. We have a fine. So we have the ball drops there, right?
Yeah.
It's a V initial.
Mm.
And then over a time of 3 seconds, it drops 9.8 meters, right?
Mm-hmm.
And this is the tower. And then in the last second, it also drops another height of 9.8 meters in 1 second. And we have this gap here that we don't know, right?
What?
So we know that the velocity final here is 29.4 meters per second.
So I used this equation to find VF for the 3 seconds.
Okay. How much is it?
It gives me 13.86 because I calculated for, but still, calculate for displacement. I found displacement. So go to page 4.
This one here.
4.
Remember,
We still haven't found.
remember for the first 3 seconds, right? We were able to work out the velocity at the end of the 3 seconds, which is, if it starts at V0, V1 equals 0, then it's 9.8 times the change in time, which is 29.4 meters per second. And we were then able to find how much distance it traveled.
Okay. Oh, I saw my mistake.
Yeah. So then that gave us 9.8 meters per second. Okay. And we also got that in the last 1 second, this thing traveled 9.8 meters, which is the same distance as in the first 3 seconds.
But I have a feeling like we missed something there at the beginning. Could have went wrong at the beginning.
At the beginning.
Yeah. Beginning. I
Mm,
don't know.
no, I think we're getting somewhere.
Okay.
So we have the one equation is VF.
Which one? This one.
I want this one.
Change in displacement.
Yeah.
Is
So
equals
delta
to
y equals
V initial times change in time.
initial velocity times delta t, okay,
Plus a half.
g t squared, right? Delta t squared. And the other equation is
For this one.
I think it was that one, yeah. VF squared
squared is equals to V initial squared
plus 2g delta t, delta y. Okay, so at this point here,
So at least you could make it a decent y. Because it looks like a G.
which one? This one?
Yeah.
Sorry about that. Yeah, like that. So we want to work out, okay, so for this distance here, whose height and time of travel we don't know,
We actually don't know anything
but the initial velocity,
yeah, and gravitation.
and acceleration due to gravity. Yeah. So I want to focus on that. That is why I'm saying, since we have an initial velocity there, we can play around with that. So we'll have delta y, it's fine, and that equals the 29.4 that we got there, times delta t, which we don't know, plus a half times 9.8 times delta t squared. And this gives us 29.4 delta t plus 4.5 plus 0.4, so it's 4.9 delta t squared. That's equation 1. Then here, we don't know the final velocity, but we know the initial velocity. That equals 29.4 squared plus 2, acceleration 9.8, we don't know delta y. This gives us 19.6 delta y equals 29.4 squared, and v final be the square root of 29.4 squared plus 19.6 delta y. Right. Where's the other equation that I'd written down? Oh, yeah, VF, VI. Okay, cool. We also have V final equals V initial plus how much?
Change acceleration.
Acceleration due to gravity times change in time. And we know that that's 29.4 plus 9.8 delta t, and this equals okay, 29.4 squared plus I think this could still give some result that's worthwhile. Delta y is 9.8 squared would be 81 plus 6.4, 91.
96.04.
Divide by 19.6. 4.9 delta t squared. Okay, so maybe we have that there. Do we have another equation that has a displacement?
Equation.
It's that one there with the 2 times acceleration. The last one, the neglected one.
Yeah, the forgotten child.
I want to say, can I put that 4.9 delta t there? Let's try that. And this equals VF plus VI over 2 times delta T. So now we've got equals, let's multiply that by 2, equals VF plus VI times delta T and we also have the initial velocity, 29.4 plus VF equals 9.8 times just delta T. And now we've got a third equation that has VF. So 9.8 delta T minus 29.4 equals V final. Okay.
I think you're going somewhere.
We just went around in a circle.
But not anyway, because that's literally the same equation that you
Yeah. Literally went full circle. Phew. Okay. This is I'm gonna have to investigate this one.
I thought the type of questions they ask us in exam.
These are the types of questions you get asked in exam. Okay.
We're clueless of what's going on.
Yeah, this is exactly the kind of. I think we should end